For most of the space age, satellites have lived like sealed appliances. Build them on Earth, launch them once, and hope nothing important breaks. When the fuel runs low or a mechanism fails, a machine worth hundreds of millions can become an extremely expensive piece of drifting hardware. But on July 21st, a spacecraft launched with 2 robot arms and a very different idea. What if we stop treating satellites as disposable? This is TrendSpark, where we follow the signal behind tomorrow's technology. The spacecraft is SpaceLogistics Mission Robotic Vehicle, carrying the robotic payload developed through DARPA's RSGS program, with the Naval Research Laboratory and NASA support. A Falcon 9 placed it into an initial orbit with 3 smaller mission extension pods. The launch succeeded. The repair mission has not happened yet. MRV is now beginning an approximately year-long climb using efficient electric propulsion toward geosynchronous orbit, about 36,000 kilometers above Earth. Only after it reaches that neighborhood can the most difficult demonstrations begin. At geosynchronous altitude, a satellite circles Earth once per day. That allows communications, weather, and national security spacecraft to remain over the same region. It also places them far beyond any routine human repair mission. Hubble could be reached by astronauts in low Earth orbit. A technician cannot simply visit the geosynchronous belt. Until recently, the practical strategy was redundancy. Test everything brutally, carry spare systems, budget the fuel carefully, and accept that many failures would be permanent. Robotic servicing challenges that assumption. It turns a satellite from a finished product into something closer to infrastructure. This did not begin with robot arms. In February 2020, SpaceLogistics' first mission extension vehicle docked with Intelsat 901. A second vehicle docked with Intelsat 1002 in April 2021, directly in its operational geosynchronous orbit. Those vehicles did not repair the satellites internally. They attached at the propulsion structure and used their own engines to control the combined spacecraft, proving that commercial life extension could work. MRV adds dexterity. Each arm has 7 joints, a tool drive, cameras, lighting, and access to interchangeable servicing tools. Its first headline job is expected to be installing mission extension pods, compact propulsion modules that act like orbital jetpacks. The servicer must find a pod, capture it, carry it to a client, approach that satellite safely, attach the pod, verify the connection, and then leave without disturbing the spacecraft it just touched. DARPA says one pod is designed to add 6 or more years of operation. MRV itself is expected to serve for more than a decade. Inspection, relocation, upgrades, and anomaly resolution are also part of the planned capability. Those are goals, not completed achievements.
Okay, orbital roadside assistance sounds brilliant. But here is the uncomfortable question. If a robot can repair your satellite, how do you prove it came to help?
Before trust comes physics. 2 spacecraft moving through orbit must first agree on position, velocity, attitude, and timing with extraordinary precision. A target may be decades old and was probably never designed for a robotic visitor. Reflective insulation, flexible solar arrays, and unfamiliar structures complicate navigation and contact. Touching creates forces. A small mistake can start a rotation, damage a surface, contaminate an instrument, or create debris where nobody can sweep it up. A separate servicing mission in low Earth orbit made that difficulty painfully current. Catalyst's Link spacecraft launched in July to attempt a boost of NASA's Swift telescope. Late that month, Link developed attitude control trouble and intermittent communications. Teams were still working on recovery. It is not MRV, but it is a reminder that reaching orbit is only the opening move. If servicing works, the economics could be powerful. A satellite may still have functioning electronics, antennas, and solar arrays when propellant becomes the limiting resource. Adding propulsion could preserve years of service without manufacturing and launching a full replacement. Inspection could also reveal whether a strange signal is a minor defect or the beginning of a mission-ending failure. But the market has a chicken and egg problem. Operators hesitate to design serviceable spacecraft before servicing is routine. Providers hesitate to build fleets before enough customers exist. The United States Government Accountability Office says demonstrations remain limited, demand is fragmented, and regulations and standards are still unclear or emerging. That uncertainty matters because the same precision required to help a satellite can also be used to inspect it closely, move it, or interfere with it. That does not make MRV a weapon. Its announced missions are cooperative, and satellite owners authorize the service. But capability changes the security calculation. Operators need clear consent, reliable identification, transparent maneuver plans, shared safety standards, and evidence that a servicer is doing exactly what it claims. DARPA plans to transfer the program to the United States Space Force after the initial demonstrations, while SpaceLogistics continues commercial operations. The technology is therefore both an engineering platform and a test of whether commercial, civil, and military space users can build trust around close proximity operations. The best long-term answer may not be ever more capable robots improvising around sealed machines. It may be satellites designed from the beginning to receive help. Standard grapple points, refueling ports, modular payloads, and shared digital interfaces could make servicing safer and cheaper. A failed component could be replaced. A sensor could be upgraded. A spacecraft could move to a new role instead of becoming debris or retiring early. That is the larger promise, not one heroic repair robot, but an orbital economy where valuable machines can be maintained, inspected, and improved. MRV has crossed the first gate. It launched. Now comes a year-long journey, then commissioning, demonstrations, and the first real servicing jobs. If those steps succeed, July 2026 may be remembered as the moment satellites began changing from disposable products into maintainable infrastructure. If they fail, the attempt will still reveal what standards, interfaces, and safeguards the next generation needs. In space, even a repair mission can teach us how to build better. Before we build the next episode, help us improve this one. Were the sources clear? Did Spark's direct question sharpen the story? Was any section too fast, too technical, or not technical enough? Tell us what worked, what should change, and what we should investigate next. We will read your comments before the next TrendSpark production begins.